Okay, so we're looking at page 4 of the 2017 Stat Test 3 review. So the first little topic there, design of a study. Student wishes to conduct a study to determine if there's a correlation between the number of hours of homework assigned per week in math class and the grade earned in that class. All right, so that's what we're going to investigate. So part A, asking whether it's an observational study or an experiment. It's going to be an observational study. And that's because, as far as I can consider, there doesn't appear to be any treatment. All right. I can't envision a situation where a student would be able to impose a treatment on other students anyway. All right, but maybe there's exceptions to that. What, if any, are the lurking variables? We'll start with aptitude. It's math class. I mean, are you naturally good at math or otherwise? Other possibilities are, living environment. A little vague there, but what I have in mind here is, I grew up in a house with 5 siblings, so a total of 8 people living in the house, including the parents. If I needed to carve out some quiet time to do some work, it wasn't the easiest thing in the world to come by. So, that's kind of what I have in mind for living environment. And again, number of hours of homework, the quality of homework. Right. So, like, what kind of questions make up the homework? Because after a period of time, you start thinking about, like, oh, I've done the same type of question like 30 times. After I've done it like 2 or 3 times, I think I got the hang of it. It doesn't matter if I do it 100 more times. My understanding of it isn't going to improve anymore. What do you expect the results of the study might be? The answers on this would vary, but as long as you have a reasonable justification, it's going to be good, or at least in terms of credit is concerned. So what I'm going to do is I'm just going to give my response in the form of a graph. And there's nothing wrong with doing that. All right, so number of hours. Talking about grade. My thinking is that the number of hours, the correlation between the number of hours and grade would have some kind of positive relationship until you get to a certain point. And at that point, you've mastered the concept. Doesn't matter how many more hours you put in, it's not going to get any better. And that cutoff could be, whatever the desired cutoff is. It could be an A, it could be a C, it could be whatever it is that you're aiming for. So if you're studying for a C, then that's probably what you're going to get in terms of, a reasonable expectation of a grade. Should randomization be used? It depends on the study. A student wishes to conduct a study to determine if there's a correlation between number of hours of homework assigned per week in math class and the grade earned in that class. So this sounds like a particular class. So if we're dealing with one particular class, you can go either way, but my thinking is if there's, let's say, 30 students in the class, why not poll them all? Maybe use a census rather than a random sample. All right. Now, you could, for this question, and I've encouraged this in the past, should randomization be used? Yeah, sure. Why? Because it should always be used. Can't go wrong if you randomize. It reduces bias. All right. But if you're gonna poll an entire population, that's the best possible outcome. It's not always practical. Now, if we're talking about all math classes at WCC or John Jay High School where I teach, then it might be a different story. You may not want to poll every individual, might not be able to get a hold of every individual, but if you can, you should. All right. Next up is a one population proportion situation. Looks like I get a little typo here in terms of the notation. That alpha is a little elevated, so I'll take that as a bonus point typo. CEO of a software company is committed to expanding the proportion of highly qualified women in the organization's staff of salespersons. He claims that the proportion of women in similar sales positions across the country in 1999 is less than 45%. Hoping to find support for this claim, he directs his assistant to collect a random sample of salespersons employed by his company, which is thought to be representative of sales staffs of competing organizations in the industry. The collected random sample of size 50, n equals 50, showed that only 18 were women. Test the CEO's claim at the 0.05 significance level and report the p-value. Do you find statistical support for the hypothesis that proportion of women in similar sales positions across the country is less than 45%? So that's what we're looking to prove or disprove. P is less than 0.45. Okay. Now, because that's a less than symbol, that's an alternative hypothesis, which means that the corresponding null would be the same stuff, just with an equal sign. And this would be a one prop Z test. All right. We're not talking about means, so we know it's not a t-test, and we're only given information about one population. So this is my one population. That sample of 50 is related to just individuals dealing with the CEOs of software companies and so on. All right, so then we go to our calculators, because the calculator does all the work for us, which is, we talked about this in previous videos and class sessions. The fact that the calculator does the work is a double-edged sword, because it does all the work, but if you type in something incorrectly, there's really no way for me to verify what happened, what went wrong. So just be careful. One prop Z, the P sub O is 0.45, the X 18, the N 50, with a less than symbol. So the P value is going to be 0.10. Well, I'm going to write it as 1004. I'm going to go the extra digit. All right, we're going with a 0.05 significance level. So the p-value is greater than the alpha, so therefore let's not reject. So do not reject the null hypothesis. All right, so conclusion time. There is insufficient evidence to reject the claim that the population proportion of, well, it's women in similar sales positions. Yeah, so women salespersons is 0.45 at the 0.05 significance level. All right. So the claim that it is less is going to be false. Therefore, and by the way, the fact that the question is talking about 0.45 being the cutoff, that's a little suspicious. Like, why wouldn't it be 0.5? You know, so what is a CEO up to? You know, something fishy, I would think. So therefore, the claim that it is less, because now we know what it is the population proportion of women salespersons, is, well, we did not reject the null, so the null is what we're going with, which means the alternative is the one that's false. Okay, so I think I'm going to chunk these videos